Okay, please look at your very last sheet, your very last sheet. Right here. These are the sets of formulas that you get on your next test. If you flip it over, these are the other formulas you get on the next test. I'm going to teach you how to use them. I'm going to teach you where they are located. I put this sheet together. I think it's very useful. Challenge to you. I always felt like if I was given a sheet of formulas on the test, I felt like I didn't know it well enough. So if you want to try to memorize these for the test and not use a sheet, go ahead. Okay? Or if you'd like to use a sheet, that's up to you. But this is probably one of the most commonly asked for sheets. So Maya goes off to college. She's going to have to take Calc 2 maybe. And so she's taking Calc 2. She's like, hey, Mr. Gens, we have to know some of these trig things. Could you send me that sheet that I had when I was in high school? And I just emailed that to her and she used it. So a lot of people ask for this one. It's very important. You can either rip this off or keep it there, but we're going to use this multiple times today. So we go to the very beginning, start here, and we have this function, a function that you are very familiar with. The graph of y equals x squared. Y equals x squared. I'm going to bring you back to something because we're going to have to relate it to trig functions in a second here. So I'm going to give you a base for your understanding. Do you remember if y equals x squared is an even function or an odd function? It is even because the exponent is even, but even more so because if you do this, f of negative x. If I plug a negative x in an I squared, what happens? Yeah, you just get out your original f of x, and that's what makes it even. That's the test that we used. Remember plugging in our negative x's? Done that many a time. X cubed, do you remember if that's even or odd? It is odd. And so f of negative x, what happens there is if you plug in a negative, you get out the same value as if it was positive. It's just negative, right? So like over here, if you plug in a value on the right, you get a positive. Plug in a value on the left, you get that same positive value, correct? But if you jump over here, if you plug in a value on the right, you get a positive. On the left, you get the same value, it's just negative. So you get negative f of x. So we can see how that works with these even and odd exponents, but what about our sine, cosine, and tangent functions? So I'm going to draw a sine function here. That's sine of x. I'm going to draw the cosine function. Yeah. And I'm going to draw the tangent function. And I want you to look at the graphs. Is sine of x, do you think that that's an even function or do you think it's an odd function? It is odd. Do you think cosine of x is even or odd? It is even. We'll pick up with this when we get back. Go get some brain food, come back smarter, and we'll be ready to go. She'll help you figure it out. Here we go. Look at the tangent function. Is that even or odd? It's odd. Very good. So this is where we come to this point. I'm going to show you why these are the way they are. Otherwise, it's just like memorization. I hate memorization. So sine of negative theta, if sine is odd, then look at what happens to the negative. It moves to the outside. So sine of negative theta becomes negative sine of theta. And cosecant of negative theta is negative cosecant of theta. Cosine's even. What happens for the even function? What happens to the negative? Just goes away. So cosine of negative theta is cosine of theta. And secant of negative theta is secant of theta. Tangent negative theta, since it's odd, negative moves the outside. So negative tangent theta, a negative cotangent theta. There's going to be some point you're going to use those and you're going to say to yourself, well, why is that true? You have to go back and rewatch a lesson, folks. Sometimes it doesn't fully click the first time you see it. But that's an excellent description of why these work out the way they do. Furthermore, if you flip to your very last page, you can see that they're all there. And I don't know how many times people look at this sheet and they say, well, even in odd identities, boy, why does the negative move to the front for sine and for tangent and for cosecant and so forth? And then why does the negative just go away for cosine? If you want to know why, you got to watch the video again. It happens to do everything with what we explained with the shape of the graphs, okay? And so there you have it. So let's use some of these pieces, okay? Today our goal is to simplify trigonometric expressions. For example, suppose you had 12x over 3x squared. Does everybody agree that would simplify to 4 over x? So we want to do that same thing, except we want to use trig functions. There are 4 or 5 different methods that we use for simplifying trigonometric expressions. I cannot tell you which method to use. I can only give you all sorts of options and show you many examples. In the end, you have to decide how to do it. Like you're solving an equation, it's kind of a process every time, right? Not the case here, folks. It's kind of like putting together a puzzle. Sometimes you just got to try stuff and look for what kind of fits, right? Here's the first way that we simplify trigonometric expressions. You write things in terms of sine and cosine. Sine of theta over 1 times. So I have sine times secant. Secant is the same as, it's related to what other function? Cosine. What is the relationship between secant and cosine? They're reciprocals, right? So secant is 1 over cosine. So as I multiply those, what I get is I get sine of theta over cosine of theta. Hey, I wish sine over cosine was something special. It's tangent. And so therefore, sine times secant comes out to be tangent of theta, and that is your simplified expression. I used to show about 4 examples during this time and give the worksheet. That didn't work out very well. We're going to do a ton of them, and hopefully you'll see the connections that build. I do cotangent times sine. I'm going to rewrite cotangent. Cotangent is what in terms of sine and cosine? Cosine over sine. Times sine of theta over 1. What happens? The sines cancel, leaving you with cosine of theta. You see, folks, I've listed all these for you right here. You look at this sheet, tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is sine or cosine over sine. That's how we rewrite things in terms of sine and cosine. Okay? Now, some people say, they're like, well, why didn't you rewrite sine as 1 over cosecant? Our goal is to write it in terms of sine. If it's already in sine, don't change it. Okay? So that's part. I got to laugh from my Michaela there. Sorry, Michaela. I called you Maya for a second there. Sorry. I don't know why that would happen. Sorry. Yep. Nicely played. Nicely played. Yes, they are. All right. Secant times cosecant. 1 over cosine times 1 over sine. What cancels? Nothing. Nothing cancels. We learned that cosine divided by sine is something special, and sine divided by cosine is something special, but cosine times sine, that's not anything special, is it? In fact, this doesn't really simplify at all. Every once in a while, we might come across an expression that it is already simplified. I want you to try D and E on your own. Ready? Go. Okay, let's check it out. Cotangent is cosine of theta over sine of theta times 1 over cosine of theta. Cosines cancel, and when the cosines cancel, what are you left with? And what is 1 over sine? Cosecant of theta. In this situation, you have sine of theta over cosine of theta, and you're going to multiply that by 1 over sine of theta. What happens? Sines cancel, leaving you with 1 over cosine. What is 1 over cosine? Secant of theta. What's different about letter F? You got some, you got 3 of them, you got some negatives, right? Let's deal with those negatives. What happens to secant of a negative? Just goes away. What happens to cosecant of a negative? Goes out front. What happens to cotangent of a negative? Negative goes out front. So how many negatives do I have? So they can be positive or negative. Positive. So we handled our negatives, they're gone. So I have 1 over cosine of theta times what? 1 over sine of theta times what? Sine of theta over cosine of theta. Thank you. Cotangent is cosine over sine. I was actually thinking about the next problem. I just listened to whatever you said. So what happens? Cosines are gone. What are you left with? 1 over sine squared. Anybody want to guess what 1 over sine squared is? Well, 1 over sine is cosecant, so 1 over sine squared is cosecant squared. Letter G, I've got tangent of negative theta over secant of negative theta. Let's deal with those negatives. Secant of negative theta becomes what? Just positive secant, right? So on the bottom, I've got 1 over cosine of theta. Top, I've got tangent of negative theta. What happens is negative for tangent? Yeah, so negative tangent is going to be negative sine over, do you think it's negative cosine or positive cosine? Positive, because it needs to be a negative expression. So you can only have one negative. Can't have both of them. How do I handle that? Multiply by the reciprocal times cosine of theta over 1. Cosines cancel, negative sine of theta. We're going to skip H and J. We're going to do I, K, and L. It's because we run short in this time. Sine times secant over tangent. Sine of theta over 1 times what? One over cosine over tangent. Tangent is what? Sine over cosine. Hey, wait a minute. Before I even do anything more, let's just look at what we're going to get. You get sine of, yep, you get 1. I mean, in the top, sine over cosine is just tangent, right? In the bottom, we have tangent. Tangent over tangent is 1. Sine squared over 1 times, how do I rewrite cotangent? Cosine over sine, how do I rewrite cosecant? 1 over sine. Does anything cancel? Yeah, I have sine squared in the numerator. I have a sine squared in the denominator. We're going to cancel, leaving me with, I love problem L. Instead of multiplication, it's just addition. Be a great ACT problem. It's rather simple now that you've learned what you're supposed to do. I've got tangent of x. What happens to the cosine of a negative? Yeah, so it's plus cosine of x. What happens to tangent of a negative? It goes out front. So minus tangent of x. So you got tangent of x plus cosine of x minus tangent of x. Those cancel, leaving you with cosine of x. Excellent. You have learned step 1. We have about 4 levels of problems to try to look at. We're just going to look at level 2 today. We're going to do these 6 and we're going to count it a day. Look at the next problem. What is your method of madness? What's the first thing you would do for letter M? You would distribute, wouldn't you? But in fact, we're not going to do that. It's not going to help you at all. That doesn't work either. Okay, so I'm going to show you something. What's the capital of the United States of America? Washington, D.C. Don't even need to think about it, right? Don't even need to think about it. There's something else that you shouldn't have to think about either. Sine squared plus cosine squared is? We'll try again. Sine squared plus cosine squared is? Sine squared plus cosine squared is 1. Folks, that is like one of the most important mathematical formulas that you have to commit to memory. You see it sitting right there. The nice thing is I can change that formula all I want to. I could subtract a cosine squared from both sides. I'd have 1 minus cosine squared over here. What would I have left over on that side? Sine squared. In fact, I could subtract a sine squared from both sides, and I'd be left with what? Cosine squared. So you have really now 3 formulas. You got sine squared plus cosine squared is 1. You've got sine squared is 1 minus cosine squared, which is sitting right here for you. You've got cosine squared is 1 minus sine squared, which is sitting right there for you. Turns out that these both factors, they are difference of squares as well. And that doesn't just work for sine squared plus cosine squared, but for 1 plus tangent squared is secant squared. You can see these nice, important formulas that result from it, as well as 1 plus cotangent squared is cosecant squared, the important formulas that result from it. As familiar as you can be with those, the better off you are. The less you have to look at your sheet to figure those out, the better off you will be. Anytime for this time forward, I say, what is sine squared plus cosine squared? You will say 1. And anytime I say 1 minus sine squared, you will say cosine squared. Anytime I say 1 minus cosine squared, you will say sine squared. So therefore, if you look back at our problem that we were looking at, let's take a tough problem, make it easy. I wish I knew what 1 minus cosine squared was. Sine squared of theta times cosecant. Well, all of a sudden, one substitution allows me to make the problem just like how we started. I know how to solve this. I've got sine squared over 1 times 1 over sine. Sine squared over 1 times 1 over sine, what do I get? Sine of theta. Boy, I wish there was something that told me what secant squared minus 1 was. I wish there was something that told me what cosine or secant squared minus 1 was on your sheet. It is tangent squared. Anytime you get a squared and a 1, there's a chance that something pairs up with it. Do we know how to simplify that? Yeah. You got cosine squared over 1 times sine squared over cosine squared. What happens? Cosine squareds are gone. We're left with sine squared. Letter O. I wish I knew what secant squared minus 1 was. So I get tangent squared over sine squared. Doesn't that look just like a problem that we did on the first page? Sine squared over cosine squared over what? Sine squared over 1. What do I do with that bad boy? Multiply by the reciprocal. What happens? Sine squareds are gone. What are you left with? What is 1 over cosine squared? Secant squared. Letter P is easy. Tangent squared minus tangent squared is just 0, right? Yeah, so you get sine squared. Exactly. We just did a bunch of voodoo math. See? All you were so happy to do that. If I asked you to do 10 minus 10 times 2, would you just cross off those 10 to say I get 2 out of that? Yeah, you guys are, yeah. Yeah, he does hate math. Everybody has their faults, so. All right. Yeah. So let's change the problem because I've learned over the years, model with an easier problem. That's something that I've learned to be successful at math. There's a lot of things I'm not good at, but I am good at math, folks. And this is one thing I do that makes life a lot easier for me. I find an easier problem. I try that one. X squared minus x squared times y squared. If I want to rewrite that, what would I do? Starts with an F. It rhymes with actor. Factor. Factor out what? And you're left with 1 minus y squared. So I'm going to model this problem like that. What can you factor out of here? Tangent squared. When you factor out the tangent squared, what are you left with? Cool. Wish I knew what 1 minus sine squared was. Yeah, so I get tangent squared times cosine squared. Isn't that the same as what we just had up above us? Isn't that the same thing we just did up above? So I get sine squared out of that, don't I? We're going to skip Q, we're going to look at F, and then we're done for the day. What do you factor out for R? Factor out cosine squared. What are you left with? At this point, I wish I knew what 1 plus tangent squared was. And I love that because what do I recognize about cosine and secant? They are reciprocals. If you multiply two reciprocals, you get 1. I want to be clear, folks. You need to show all of your work when you do these problems. I will be looking at all of your work come test time. Because the fact is, sometimes people guess. They guess 1 or sine squared. And you know what? You got a decent chance to come up with the right answer. I award 0 points. I will not be laughed at.